Hello, in this little mini video we're going to talk about balancing chemical equations. A lot of students usually have issues with balancing chemical equations because they can't really see what they're allowed to do, what they can't do, and really what they end up doing means. So let's take a look at a very simple basic chemical equation. We have nitrogen reacting with hydrogen giving us ammonia. This is called the Haber process. So the number one chemical produced in the world is ammonia, and this is a reaction which undergoes it. We have the reactants on the left of the arrow, we have the products on the right. The arrow means yields. And in balancing chemical equations, we need to get atoms in equaling the atoms out, because as we know, the law of conservation of matter, no matter can be created or destroyed. And in balancing chemical equations, the same holds true. All right, so let's get rid of that. Go back to the pen. So how do we go about that? Well, you've learned that we adjust these stoichiometric coefficients. All right, well, that's great if you can really see this, but if you can't see what's going on, it really doesn't help you. The areas in front of each of these where I just had underlined are where we're going to put coefficients, and this is nothing more than how many? The number of that molecule. The number of that molecule and the number of that molecule. How many we're going to need in order to get this to balance. All right. So let's see here. Let's go backwards a little bit. So let me actually go a little farther back. So let me show you a way to see this. All right, let's put a big equal sign there. All right, let's put a line here. Now, if you don't have a number, you know it's understood to be 1. So we're going to write N2 as N bonded with N. I'm not doing Lewis dot structures. We have H bonded with H, and we have N bonded with 3 H's. All right. So here we have the reactant side, and we see we have 2 nitrogens. Here on the product side, we only have 1 nitrogen. Now we can just put an N in here, but that's not what the product is. Okay, the product is NH3, so in order to bring another N in here for the 2 N's on this side to equal the 2 N's on this side, we need to bring whatever's on this side that's going to give us N's, and that's going to be another ammonia. All right, so see, we have now 2 ammonias, and now our coefficient's going to have to be 2. Now it might not stay 2, who knows? All right, so let's take a look. We have 2 nitrogen atoms on the left side, and now we have 2 nitrogen atoms on the right side. Let's look at hydrogen. We have 2 hydrogens on the left, and we have 6 hydrogens on the right. All right, how are we getting hydrogens on the left? They're getting them from H2. All right, so we bring another H2 in. That's 2, that's 4. We're not at 6 yet. All right, we bring another H2 in. Now we're at 6. How many H2s did we have? We had 3. Now let's verify. We have 2 N's. 1, 2 N's. That's good. 1, 2, 3, 4, 5, 6 H's. 1, 2, 3, 4, 5, 6 H's. This is a balanced chemical equation. It tells us that 1 molecule of nitrogen, N2, and 3 molecules of hydrogen, H2, will give us 2 whole molecules of ammonia, NH3. And this is how you balance chemical equations. You can do this for any of the formulas. Now, or any of the chemical equations. I would suggest if you start doing it this way, if you're really stuck and this way helps, that's fine. You can start doing them this way, but as they get more complex, this is going to get really messy with a lot of molecules here and there. This illustrates the method very well for a very simple reaction, and hopefully this shows you how it's really done. And it's just like a recipe. 1 of these and 3 of these is going to give us 2 of this. Now, don't fall into the pitfalls that many students do. Many students will balance a chemical equation by changing the formulas. All right, N2 is N2, you can't change it. H2 is H2, you can't change it. NH3 is NH3, you can't change it to get it to balance. All right, only alter the stoichiometric coefficients, and that would be these areas here. One last thing about stoichiometric coefficients, they must be integers. Must be integers. Why is that, do you think? Integers, integer. Nope, I can't spell today. I can't spell at all. I'll just rewrite that. They must be integers, whole numbers. Why? Because you can't have part of a molecule. You can't have part of a molecule. You chop N2 up, it's no longer N2. You chop NH3 up into something else, it's not NH3 anymore. You must have the coefficients be integers. And if you get it to balance and you have a non-integer coefficient, then you have to multiply them all by a common factor so they become integers. And you'll see some of those examples on the combustion.